Okay, so I figured I'd do these word problems for you because the rest of it you can do with just an applet to check your work. But with this stuff, so what they're asking me to find is find the height of the balloon. So I am looking, when I'm all done, I need that distance there. So, but for now, let's see. They're telling me this person looks up at the balloon, and that's a 25-degree angle. And this person looks up at the balloon, and that's a 40-degree angle. So is this a right triangle? Well, let's see. Those should add up to 90 degrees if it is, because if that was a 90-degree angle, and they don't. So it's an oblique triangle. We need to use law of sines for this, or law of cosines. We don't know which yet. Well, and we'll see what we have when we finish filling in the sides and see what pattern we have. We know A and B are 4,000 feet apart, so this side is 4,000 feet. I see an angle side angle pattern. So this is a law of sines problem. And what's kind of nice about this one is I can find that angle pretty easily by taking 90. I'm going to take I'm going to take 180 degrees. I'm going to lose all my writing. See if I can erase. Oh, I can. So I'm going to take 180 degrees, and I'm going to subtract the sum of 40 plus 25. So I think that's 95 degrees, isn't it? No, that's not true. It's 115 degrees. So that's 115 degrees. So then, because I've got this nice angle side pair, definitely an law of sines problem. So I know that 4,000 over the sine of 115. Now, why am I setting? Well, I know those are the angle side pair, but why do I want to do that if I'm looking for that yellow altitude? Well, if I can find, let's see, let me go with green. If I can find that side, then I've got a hypotenuse, because that's a right angle. And then I can just use SOHCAHTOA, or actually sines, sine there, right? The opposite. I want the opposite side, I'll know the hypotenuse. So let's find that hypotenuse. So that tells me the sine of 40 degrees is the angle. And that hypotenuse is what I want. So then I'm just going to grab my handy dandy calculator, cross multiply, divide. And when I did this earlier, I came up with about 2837. It was in decimals, so I rounded. So now I've got this angle. I'm looking for the opposite side. I know the hypotenuse. Let's just use sine, because opposite hypotenuse, right? So I know the sine of 25 degrees equals the one I want over 2837. So that just means, because this is really over 1, right? You just do the cross products. And you do this times this, and that should be the answer. And when I did this earlier, I came up with 1,199 feet. Okay, so now they're shifting everything over to the one side. This is the 44,000, and this is 25 degrees, and here's the 40 degrees. And they still asking us to find the altitude or the height of the balloon, so we want that side still. Let's see. Don't I know if I knew that? So same deal. Let me give you my thinking here. If I can find that hypotenuse, because that is a right angle right there, right? If I can find that hypotenuse, I can do the same thing. Sine of 25 equals x over however big that is. So I am looking for this side right here. I want that side. I do know that this angle here is going to be 140 degrees, because they're supplementary, right? So that angle's 140 degrees. And then this side is opposite this angle, so I need to find that angle. Fortunately, that's not going to be hard to do, because 25 plus 40 is 160, 140 is 165. And if I subtract that from 180, that angle is 15 degrees. So now I can say 4,000 over the sine of 15 equals, I don't know, the one I want over the sine of 140. And when I did that earlier, I came up with 9934. A little bit different than earlier. And now, because that's the hypotenuse, I can say the sine of 25 equals the height that I want over 9934. And then it's the same deal. 9934 times sine 25, and that'll be the height. 9934. 9,934. Sine of 25. So I'm getting, in this case, the balloon would be 4198 if I don't round. Well, if I do round, because it's 0.2. Okay, so that's feet. Alrighty. Okay, so we've got these people on an we've got these people on an east-west road, and they're 25 miles apart. And the west man, when you do a bearing, folks, I'm glad we are. I wish we could do some compass work outside. A bearing goes due north is here, so that angle is 37 degrees, and then of course that's outside the triangle. So, but let's do another one. Let's see. Then this guy over here, a person over, it does say a man, so we know this person's looking toward the tornado, and that person is spotting it at 56 degrees west, north, 50 degrees west. So this is going to be the 56 degree angle right here from north to that bearing, to that. So we've got to find, what makes this a little tricky, we've got to find that angle and that angle. So those are just right, these are right angles, right? So they're complementary. So this should be 53 degrees. And this should be 34 degrees. And then, because I know this side here, right, I really want to know that angle. So we'll add these up and subtract it from 180. Let's see, what is that? 87. So 180 minus 87, is it? That's 93 degrees. So this angle's 93 degrees. And I want to know how far is a tornado from each man? And then how far is it from the road? So I need to know this side, I need to know this side, and then I need to know that vertical distance. So let's see here. I can say, you know what I'm going to do? I'm going to set this up. I'm going to do the law of sines 3 ways and only concentrate on 2 of them. So I'm going to say b over the sine of 53 is the same as 25 over the sine of 93, which equals a over the sine of 34. So do you see the way that I just marked up the side opposite the angle, the side opposite the angle? And of course we know that one, and I put it in the middle because that's going to be convenient. So then what we're going to do to find side B, multiply those two, divide by the sine of 93. To find A, we're going to multiply those two, divide by the sine of 93. Okay, so when I did that arithmetic, I multiplied those two, divided by sine of 23. I got about 20, it was 19 point, and rounded up. And the same thing here, and practically to the nearest mile is plenty fun when you're talking about a tornado, right? Now to find the distance from the road, now that I know that, well, I don't care. Let's see what I'm going to use. How about if I use this 14? So I know this side is 14. Whoops, I don't want a highlighter. I want this. I know this side is 14. So can't I say the sine of 53 equals the height that I want over 14? And then we'll just do 14 times the sine of 53. And I got 11.1. So about 11.1. All of a sudden, as I'm doing this, I had a panic attack thinking I was in radian mode. And I was getting reasonable answers, so I wasn't too worried that I wasn't. But I looked and I am. I'm in degree mode. All right, so that's the first three. Oh, some more bearing work. Let's see. So a small ship travels from the lighthouse on a bearing. You know what? Just a minute here. Let me make this be a little bit more north 70 degrees east. So like here's a little compass rose. Here's the lighthouse. Here I'll use a yellow light for the lighthouse. And we know this is north 70 degrees east. So that angle right there is 70 degrees, which I hope you see that this angle is 20 degrees. And then it turns to the right, and it travels, and it doesn't tell us how far it turns to the right, but it does tell us it travels for 5 miles and finds it directly in the beam of the lighthouse. Now, this is due east, and it tells us it shines east. So we're looking for, let's see. It feels like I need to have another, 8. Here we go. It travels for 8 miles. I missed that piece. Here, let me highlight that. So that 8 miles I need. There's a 5 I need. I need that 20 degrees. So I spy with my little eye this. I want this side, right? I want that. The trouble is I have an angle side pattern. So there could be 2 answers, but maybe not. But we won't go there because I think because this is a real life example. We'll say, I don't know. I'm going to look at that. But anyways, here's what I did. So I know 5 over the sine of 20 gives me that relationship, and I know if I can find that angle, I know that side. If I can find that angle, then I can find that third angle by adding them and subtracting from 180, right? So if I know that this is 8 and I want the sine of angle, I don't know, let's call it angle E, though let's just call it angle B. It doesn't really matter. So then I'm going to multiply, grab my calculator, multiply those two, divide by 5. And what that's going to tell me, did I do this earlier? Did I actually write down the numbers? Yes, I did. When I did this earlier, I got, here, I'm also going to erase this due east so I have some little room to write. When I did this, I came up, the sine of angle B equals, let me use a capital letter for angles, try to be consistent. I came up with 0.54772. And then I did the arc sine of that, and I came up with the measure of angle B. The measure of my angle B that I labeled B was about 33 degrees, it looks like. Well, so let's see. So now this is 33. Whoops, a pen. So this pen. Well, what's happening here? 33 degrees. Now to find that angle, we're going to do 180 minus 53 degrees because 20 degrees and 33 degrees is 53 degrees. So that's going to be what? 127? So then I can say 5 over the sine of 20 equals, I don't know, that's the side I want, over the sine of 127. And we'll do this cross product. We'll do this times 5 divided by the sine of 20. And when I did this earlier, I got about 11.7, about 12. So I came up with x equals, let's see, 11.7. So many of you know a lot more about baseball than I do, but here's how you can do this question. So here's the baseball diamond. We know that each of these are 90 feet on each side. And so then I had to do some looking. I didn't know. I mean, is the pitcher mound exactly in the middle, and exactly in the middle of that diamond? You know, if you draw the diagonals, is that exactly where the pitcher mound is? If it were, well, if you think about, this is a 45 right triangle, so that side, this side here, whoops, come here. This side right there, remember that L square root of 2 pattern? Well, this will be 90 times the square root of 2, and half of that, did I write that down somewhere? I don't think so. So, I mean, what does that mean as a real number, or as a decimal number? So 20 times the square root of 2, or 90 times the square root of 2. Let's see, square root of 2. Oh, boy. Square root of 2. I'm going to cut that in half. So half of that is about 63.6 feet. And they're telling us that the center of the pitching mound is 60.5. So it's not quite in the middle, is it? It's close, but it's not quite. So what I'm seeing is this. So this here, actually, let me go. That green side is the side they're looking for. How far is the pitcher's mound from first base? So what do we know? Let's step back here and what do we know? So I abstracted the pitcher's mound to what we're looking at, and we knew this is the distance from home plate to the pitcher's mound. We know that's one side of the field, and that angle is 45 degrees because the distance from third base to home plate or that angle is also 90 feet, and that makes this a square, right? So half of it's 45. So what am I seeing here? I'm seeing a side angle side. Well, when you have a side angle side pattern, you don't know the opposite side, right? I don't know the angle on the opposite side, so I can't use law of sines. It didn't tell me anything else. So this is a law of cosines pattern. So x squared equals 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45 degrees. And you just grab your calculator, type that in exactly like that, and then you take the square root. And did I actually write down the answer to this? I did not. I came up with x squared equals 4,059.86-ish. So if I take the square root of that, do I get a reasonable answer? I do. I got that x equals the distance from the first base to that pitcher's mound. It says 63.7. How close is that to the actual distance? I don't know. I think I did it right. It seems reasonable. So why don't you, if you want, go check it out and let us know. Okay, what do we got going on here? Let's see. We've got the distance from A to C is what? 865. And BC is 188. And we know this angle is, let's see, 42 plus 18 divided by 60. Remember, we got to change the minutes into degrees. So 42 plus 18 divided by 60, 42.3 degrees. And again, that looks like another law of cosines question, doesn't it? Side angle side. So x squared, see this is the x squared, I guess I could do c squared. X squared equals 865 squared plus 188 squared minus 2 times 865 times 188 times the cosine of 42.3, was it? And you just key that right in your calculator just as it is. Don't hit equals till the end. So I got x squared equals 54, let's see, 543,011.3827. Not that we need all those decimal points. And I'm going to take the square root of that. So I'm getting this distance to be about 736, 737, depending on how you want to round. 736.89 if we're trying to keep my open math happy. All right. Okay, so for this last example, they're telling us the distances between all these houses are, we know the diameters. Okay, so this bigger circle has the diameter of 900. So that we need half of that, so 450 right here. Let me zoom this in and be able to write some of this in. So this is 450. Let's see, the bigger one is, let's see, this is, and so that's 450 also. This is 350. 350, and that's 300. And that's 300. So what does that give me for a triangle? So if I abstract this a little bit, this side is 650. This side is, let's see, I have 800. And this side is 750. They're asking us to find all the angles. Well, this is a side pattern. It's one of those law cosine working backwards. I'll show you what I do with this. Suppose I want that angle. The side opposite is the 800. So let's just start setting up a law of cosines here. Let's see. I can say 800 squared equals 650 squared plus 750 squared minus 2 times 650 times 750 times the cosine of that angle that I don't know. So there's formulas, all kinds of formulas you can use to solve this. What I'm going to do is I'm just going to work backwards here. I'm going to do 800 squared minus the 650 squared minus the 750 squared to get, and that leaves me this by itself. So then I'm just going to divide this mess by this. Negative 2 times 650 times 750. That's equal to the cosine of x. And then we're going to calculate this, grab your calculator, calculate that, and then we're going to arc cosine it, and that'll tell me that angle right there. Just so you can check yourself, when I did this, I got the cosine of x equals 0.3538 with a bunch of other decimals. So then I found the arc cosine of that. So I got the measure of angle, my measure of angle x equals 69.3 degrees. Since we're not trying to keep my open math happy, that's probably close enough. So what does that do for us now? Well, since I know that this angle is 69.3 degrees now, I have an angle side pair, And I can use the law of sines now. I've only got to use this law of cosines things once. And I can find either one of these angles. And then once I find that second angle, I can just subtract it from 180. So then I can just, so like I said, the law of sine, so I can say 800 over the sine of 69.3 equals, I don't know, 750 over the sine of A. And if I wanted to, I could even say 650 over the sine of B, though I don't need to use the law of sines for that. So then we're just going to multiply those two and divide by 800, and then we'll arc sine it. And I'm thinking this, I mean, looking at this is certainly looks like these are all acute angles. So I don't think I need to worry about finding obtuse angles here. So I'm getting the sine of angle A equals 0.876, I don't know, 98. I mean, it's a lot of rounding going on there. So then I'm going to arc sine that. So second sine that answer, I'm getting 61 degrees, so 61.3 degrees. So that's 61.3 degrees. So then I can add those two together, subtract it from 180. I could do the law of sines with those two proportions, same deal, So you get the idea here. So this video is going to be way too long as it is. Watch it in double speed, even if you want to. And I'll do my answers. I'll do the answers for the homework exercises for these word problems.